Imagine standing at the base of a skyscraper that is about to defy gravity. You aren't just looking at metal and wires. You are looking at the most volatile, precise, and expensive machine ever conceived by the human mind. Most people see a rocket and think of a majestic climb into the heavens, but they never think about the thousands of microscopic decisions that keep it from turning into a fireball on the pad. What happens next is a journey into a world where a single grain of dust or a fraction of a millimeter of error can mean the difference between satellite deployment and a multi-billion-dollar catastrophe. Going to pull back the curtain on the assembly line, where raw is transformed into the most sophisticated vehicle in existence. This isn't just manufacturing. It is a high-stakes ballet of robotics, aerospace-grade metallurgy, and raw human grit. You might think you know how these titans are built, but the truth is far more chaotic and fascinating than anything you've seen in a textbook. And trust me, once you see how these machines are born, you will never look at the night sky the same way again. Imagine standing at the base of a skyscraper that is about to defy gravity. You aren't just looking at metal and wires. You are looking at the most volatile, precise, and expensive machine ever conceived by the human mind. Most people see a rocket and think of a majestic climb into the heavens, but they never think about the thousands of microscopic decisions that keep it from turning into a fireball on the pad. What happens next is a journey into a world where a single grain of dust or a fraction of a millimeter of error can mean the difference between satellite deployment and a multi-billion-dollar catastrophe. But here's the secret that the manufacturers don't broadcast. These raw materials aren't just shipped. They are tracked with the precision of a controlled substance. Every single batch of metal is analyzed, stress-tested, and documented from the moment it leaves the earth to the moment it hits the factory floor. We are talking about raw costs that can exceed tens of thousands of dollars per kilogram, and that's before a single worker has even touched it. If one batch of alloy contains a microscopic inclusion, a tiny bubble of gas or an impurity, the entire structure could fail under the pressure liftoff. But wait until you see what happens when we start melting this metal down, because the heat is about to get intense. Welcome to the forge, where metal is pushed beyond its physical limits. We start by feeding giant aluminum lithium sheets into friction stir welding machines. Instead of using a traditional torch, we use a spinning, non-consumable tool that creates heat through friction, reaching temperatures of roughly 500 degrees Celsius, or about 930 degrees Fahrenheit. The metal becomes plastic-like, churning together in a solid-state joint that is stronger than the parent material itself. You can smell the ozone and the faint, metallic scent of heated alloy as the machine moves at a steady, rhythmic pace, pressing with over 15,000 psi to ensure a seamless bond. Now, watch the fuel tanks take shape. These aren't just containers. They are cryogenic pressure vessels designed to hold liquid oxygen at a bone-chilling minus 183 degrees Celsius. The process takes hours of constant, automated monitoring, where the slightest vibration could ruin the structural integrity of the cylinder. As the segments are welded, they are hoisted by cranes that move with a terrifying, graceful slowness. What surprises most people is that the walls of these tanks are often thinner than a soda can relative to their size, yet they must withstand the immense G-force of atmospheric exit. And just when you think the structure is solid, the real test begins. We pressurize it until it literally groans. Precision in aerospace isn't a goal, it's a religion. In this section of the factory, we use laser scanners that map the rocket surface down to 5 microns. That is roughly 1/20th the thickness of a human hair. Any deviation from the CAD model, and the part is scrapped, melted down, and recycled. We run stress tests that mimic the extreme vibrations of engine ignition, shaking the A-frame at frequencies up to 2000 Hz. Our rejection rate for critical components is kept below 0.01%, an astonishing figure when you consider that a rocket contains over 2 million individual parts. But here's where the machines meet their match: human intuition. Despite all the AI vision systems and robotic arms, a veteran technician can still feel a bad fit just by the sound of a bolt seating or the subtle resistance of a part being slotted into place. There's a moment during the final engine integration where a human hand must reach deep into the nozzle assembly to adjust a sensor that no robot can reach. It is a moment of pure focus, where the engineer's hands are steadier than any actuator. And as they tighten that final connection, you have to wonder, what happens when we combine this level of human skill with the cold, unyielding precision of the machines? The rocket industry is a massive, silent engine of the global economy, worth over $400 billion annually. We are seeing a production boom that hasn't been matched since the mid-1960s, with over 200 orbital launches now occurring every single year. The top 5 countries, the United States, China, Russia, the European Union, and India, are locked in a quiet, high-stakes race for orbital dominance. Together, they employ hundreds of thousands of engineers, welders, and software developers, turning raw metal into the keys to the solar system. Did you know that a modern rocket engine has fewer moving parts than a high-end luxury car, yet produces more power than a small city's power plant? Or that the guidance computer on today's rockets, while incredibly advanced, is built on the same fundamental principles of logic that have existed for decades? We are currently shifting from an era of expendable rockets to a future of rapid, full reusability, which is dropping the cost per kilogram to orbit by nearly 90%. We are on the cusp of an explosion in orbital logistics, and every single part you see here is a brick in that new foundation. But wait, what happens when we start building these things in space itself? We have traveled from the deepest mines of Chile to the sterile, high-tech clean rooms where gravity is defeated. It is a process that demands perfection, rewards persistence, and punishes even the slightest hesitation. You have seen how we weld with light, test with sound, and verify with math, turning simple elements of the Earth into ships that sail the vacuum of space. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the Earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.